Foods. All right, everybody, welcome. This is giant news. Tesla just dropped a demo of their Gen 2 Optimus Tesla bot. We're doing this as a co-stream on Hans Nelson channel, as well as My Tesla Weekend, Brian White. Unfortunately, I know you guys are waiting and hoping that Scott Walter will be here. He is in Germany and he's fast asleep. It's 4 a.m. I'm bugging him. I'm calling him. I'm trying to get him on the board here. Dr. John Gibbs of Dr. Know-It-All also, I've been bugging him, but he's busy with his university schoolwork. So it's just the three of us right now, but I'm going to invite other people to join as well. So stick with it. I'm going to go ahead and play the demo and let's react to it. This is massive news. Let's listen to it. Oh, okay. There's just so much to talk about there. Okay, let's get started with you guys. What did you see that's very different and new this time around?
So what jumped out at me is not, that we didn't think this was coming. What we may not have thought was that it was coming today, this soon. I thought surely this would be kept under wraps until AI Day 3, but I am delighted to be wrong on that. So
Yeah, who's been saying that there was going to be a demo drop of Tesla bot this month? I did.
Could have been anybody.
I knew it was going to happen.
So yeah, I'm just impressed that they keep they keep giving us these updates that are video updates on the bot before we've even had a special AI day or some event. That this is now we've had several of these where they'll just say, hey, here's the video, we're going to release it, put it out there and let y'all see kind of what we're up to and we're working on. And so I love the cadence of updates, and not only the cadence of updates, but the massive changes that we see in the design from, this is more than several years worth of work for most companies, what they have released just in the last few months.
Generations for some. Yeah.
Who thought that was crazy? Because just a few months ago, people were Scott Walter was saying that there might be 500 bots by the end of this year. Of course, that did not happen. And then everybody said, "Oh, the bots, that's like 3 to 5 years away from now. Robotaxi is going to come first." No, bots available now. Bots can work right now in a factory. Let's watch it clip by clip, and let's take a look. At this. That's kind of what's happening here. So Bumblebee, September 2022, right? That was originally, like you said, Hans, you said that was like, a dancing robot. Now this one looks like that dancing robot.
Bumblebee was actually after that.
It looks like a stormtrooper, guys.
Don't say that.
What my kids pointed out is that it has a similar aesthetic.
Did you see that? Did you see the head movement left and right? Somebody in the audience was pointing that out. So Optimus version 1 Gen 1 did not have an actuator in the neck. Scott Walter pointed that out several times. They've added an actuator to the neck. Did you see that? That hand movement and 2 degrees of freedom there. Also, 2 degrees of freedom actuated neck. That's a big deal. And the fingers, Scott Walter's been pointing out quite a number of times here. That is something that no other company has shown yet. No other bots. We've seen many, many bots out there. We've shown that their progress. They don't have yet the hands and the fingers, and of course, they don't have the brains. Take a look at the feet. These are still flat-footed, so Scott's been waiting for them to change that, but it's a lot more updated than it used to be. If you take a look at the old demos, you'll see that the feet are just flat steel. This is no longer the case.
That's the same number of degrees of freedom that we had before, but it is an updated design on the hands apparently that gives them, faster control, more dexterous. And then with the sensing, I love this little graphic where it shows that the Tesla bot can feel the eggs where the pressure from those are on the finger pads as it picks them up.
Yes. What is it? Brand new hands, it said there, didn't it? This is new, tactile sensing on the fingers.
Mm-hmm.
That's brand new. Because initially, Scott was saying it's just the pressure alone. It can hold a water bottle, and it knows that it's a water bottle versus a, they say a baseball bat, and then it can actually know it just by the reaction of when they're pressing hard. It now has tactile fingers.
That's so new. What he was saying is that the actuators that pull the fingers closed, that if there's resistance, that actually creates a back EMF in that little actuator that you can measure. And so you can actually measure the resistance through the amount of power that actuator has to see in order to hold its position in place. Whereas this is a direct sensor. And so that is a whole different scheme. It adds a little bit more complexity to the hands, but I think the reason that Tesla's doing this is because they feel like they get a lot more capability out of it than they give up by adding one extra sensor per finger. So, that gives you, it depends on what the resolution of these tactile feedback systems are. But yeah, definitely at least 5 sensors per hand.
So if right now it's just saying 2, right? 2 per hand. Or do you think it'll be every
finger? So it's just giving you
what's happening.
It's only touching
on every finger.
Yeah, it's only touching the egg. So
gotcha. So it's going to be all 5. Makes sense. Oh yeah, we're definitely gonna be all dancing, guys. This is too big. So let's talk business model. When you see this, oh look at this. This is a little Easter egg here. Look at that. You can see this. They always do this. They always show you another bot in the background, and somebody's working on it. So this gives you the sense that these bots are just walking around the factory, and just everybody's just doing their day job.
Yeah, I think most of the time they're actually attached there to that gantry, and that they only take them off to do these nice little videos for us. But
look at that, it's exercising.
That's incredible balance.
Faster 11 degrees of freedom, brand new hands. That is probably the biggest update right now. That's the most important. If you've got these hands that can manipulate like this, and it can learn quickly, it can do anything at this point. Because I kept. Mm-hmm.
Well, that's one of the things that I was looking for when Figure released their little demo here recently was, what do the hands look like? And they were pretty careful not to show us too closely what their hands look like. And I think they're very, very rough. And that is a key, it doesn't matter how good it can walk and run. if it can't pick up anything and use any tools or do, almost all of the work that humans do, we use our hands for. And so if you can't use good hands, then the rest of the form factor, obviously they need to figure that out. But that's one of the things that Tesla looks to be so much further ahead on is the hands that they have, which were already pretty much best in class is what it looked like. And so to actually have improvements on those already is amazing.
And what I'm seeing a lot of comments on is, why does it need to walk at all? Why does it need to have all these human features? If it's just going to work in a factory, and that's the point, is it's not going to just work in a factory. It's going to work in any space that was previously strictly the domain of humans, more or less. If there's a task that you can do, this should be able to do it.
Yeah, and so many of the jobs that are being done in a factory today, whether it's Tesla's factory or other factories, you don't actually need to walk that much. You just need to grab some item in one place and put it to another place. And usually those are very short periods. Because you know why? If it's a really far location, I did a show with Scott Walter, and he showed that there's a need for robots with wheels. There's a need for robots with legs. And there's a need for robots with kind of like modified, not even having to move at all, the stationary ones. And so each one of those, there's slight needs and, different depending on the situation. You do need legs to be able to move from one location to another if it's short. But the hands, the ability to grab something and to move it, that's what's really critical, because not every item is in a precise location, and it doesn't have to be put in another precise location. And so it doesn't make sense for those stationary bots. This thing at this point can do, I don't know, look at the heads, the head movement is just scary. And if it can handle an egg, it can certainly handle that big issue that they had where the foam in the seats, they can do that now probably.
Quite likely. Quite likely.
Yeah. So one of the things, yeah, go ahead.
That I noticed as well is, all these parts look like they're made out of plastic, and obviously the Gen 1 Optimus looked like it was made out of metal. And so I think that's one of the places where they're seeing weight savings, but it's also one of the things that will make manufacturing costs on this much, much lower. If you can have the majority of the body actually injection molded out of plastic parts, then this thing could be very, very inexpensive to manufacture at scale, and it won't even be very difficult to get to scale on at least the body. Then you would be looking at bottlenecks in things like the actuators or the computer or the batteries, other things besides the actual physical body of the robot.
So the white part on the legs there, on the calves, do those look plastic to you, or do those look painted metal?
They look plastic to me.
Wow. That would be a tremendous
Why
cost
would it need
and
to be
weight
metal?
savings, right?
Yeah, it does not need to be metal. And but this is the point of here: foot force, torque sensing, articulated toe sections. That was the thing that Scott Walter is looking for. The toe sensing. He's going to be just so happy. I guess you don't need the arch, but matters more was the toe sensing. This is,
and not just sensing, but you can see as it rolls, like there is a hinge there, and so the toes are right there. Yeah, right there.
Oh yeah. Okay, wait. If you looked at the old demos, it was a flop, 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 and that's why, by the way, people are asking, why do these bots look like they're about to taking a dump, right? They're always sitting that way because they don't have the balance, and because of their foot is flat. But now it doesn't look like it's taking a dump while it's walking anymore.
Much.
Scott's
quite as much.
It's the best walk we've seen
by far.
It's a little slow still, guys. What do you think? I mean, the speed, I think they're just showing us actual speed, real speed. They did not say that this was sped up by 1.25 or anything like that.
And the way the feet step down, like you were saying, they're flat, but they still have kind of a human paddle about them. That's a great benefit. I'd be very curious to hear what you guys, and for that matter, Scott, when he's around, have to say about the cost of manufacturing this at scale.
Was Warren right when he said 30% faster? Is that what? Oh, walking.
That's what the video said. Yeah, 30%
Oh, okay.
faster walking.
Oh,
So it's still too slow. It's still slow.
30% faster than the previous ones, not that the video is sped up 30%. Is that right?
Oh, where did it say 30% faster?
I don't know. Maybe it was on the post itself.
Yeah, it was in the section on walking.
Okay.
Okay, where's the section on walking? Did I miss it?
30%
Right
walk speed boost. Okay. So what does that mean? 30% walk speed boost. Faster than the previous? Right. They didn't speed
That's
up the
what
video.
That's what I'm getting.
I'm assuming they're saying that it can walk 30% faster now than it used to be able to.
Well, this person here says it's the video speed.
I
don't
wouldn't
agree.
agree with that.
I don't agree with that.
Agreed. Yeah. So it doesn't. Okay. So this is in all of our business models that we've done. There's CERN Basher did a whole business model. I've got a bunch of others who did this. You know, there's one point where you go, well, what happens if the bot is half the speed of a normal human? Then what happens with the same speed as a human? And then at some point, they're going to be 2 times faster than an average human and 4 times faster than an average human, right? But right now, even if they're half the speed of a human, they can be put to work. They can be work 3 shifts. They can still be cheaper and replace humans today. So the walking speed and how fast it moves is important, but it's not, critical.
Yeah. And I think that's absolutely right. I think that there are a lot of applications where you can't slow down. I would argue that a lot of factory things, especially with Tesla speed, you can't slow down. Half speed's not going to work. But there are a whole lot of situations where full speed is not required even for humans. I mean, it could absolutely be a cashier. And I know, yes, but just pay electronically and do self-check. Hey, if people don't want to do self-check, this guy can count money and dispense change. But other things like just working, behind the counter doesn't require tremendous speed. It just requires the ability to be present and alert. And then you're not taking breaks, and your foot could be standing over an inductive charging pad, so you don't need to deal with that. There's a lot of ways that this, with these capacities, would already be a commercially viable product.
What does it say here? 10 kilogram.
So this is why I think it's made out of plastic. I don't think people who think this thing is built out of aluminum understand how much aluminum 10 kilograms of aluminum is. Like, they did not remove 10 kilograms worth of aluminum from this bot. And so that's why, like, going from whatever it was before, which I assume it was aluminum before, to this is, if they're pulling 10 kilograms out of that, that's a lot of weight. That's 22 pounds. That's
a lot.
A lot. And I don't see how you can do that without going to plastic.
And plastics
without
can
sacrifice.
be very strong. Yes. Plastics
can
can
be
be very strong. Because the aluminum
it can be a brand new.
Yeah, in the showrooms is far more durable than a human bone. It doesn't need to be stronger than a human bone.
My gosh, I love that. This is the part that was really incredible right here. Look at this. It looks so human, better than a human. I could.
So because the wrists don't have a million cables, it doesn't appear to have a million cables running through them. Does that mean the actuators are within the palm of the hand? Or am I just seeing it wrong?
You're right. I mean, we need Scott Walter because we've never seen those fingers do those kinds of maneuvers before. That is amazing. So when Scott used to describe robot hands to us, you can see that when the robot like does this, the very first version of Optimus, all it did was sprung back. That's it. When it actuates to pull it back, and then it springs back. When you can see this kind of movement like this, that's no longer just springing back like that. It is now every finger is absolutely controlled somehow.
Yeah.
It's
interesting how many of the aspects they mimicked from humans. If it was me designing it, I'd have gone lazy and gone with the Disney 4-fingered hand. because it's easier than a 5-fingered hand. Yeah, I would have.
Yeah, what Scott said was that the fingers, they are 5 fingers, but I don't know if you can see this. You see the 4 fingers there?
Yes.
Normally, human has one finger, the middle one longer than the other fingers, and the pinky shorter. They made all their fingers the same length, but
Yep.
but then they offset it so that one of the fingers is just a little bit placed a little higher on the palm or the hand, so it looks a little bit taller, because it's important that they're a slightly different size. But it's important that they're all the same size, because now it's the same finger. They can mass produce this a billion times, one finger instead of like 10 different, or 5 different fingers. You know what I'm getting?
Yeah.
It looks there like on the new Palm, though, they're almost all sharing the same hinge. And so it does look like, you can kind of see it's almost a straight line there across the bottom of the 4 fingers as it's faced down there, which I think is interesting.
And the other thing that seems to be new is, how in your finger you have this, but now you can bend it. Like there's like that extra joint right here. I don't think that has, this one has it, but it has another joint. You see how it can bend it right here?
Oh, I see.
Right here.
Yeah.
That's new. It's not just one finger like that. It's actually be able to bend it. But Scott was saying it does not have that little.
Yeah, it only
bit
had two sections in the finger instead of 3 before.
Okay, here you go. Guys, you know what I miss? I wish they could talk. Yeah, you bet it's going to talk. What makes you think Grok's not going to be built in? It's going to talk, right? And you can tell it what to do. Grok voice box. Didn't we just hear this already, that it's already happening?
I haven't heard that it's happening, but I would be very surprised to find out that it isn't.
Yeah, you know what it is? I got a DM from somebody, and it was like, my uncle works at a Tesla factory, and he says to me that these bots are already going to be working in these factories, and that you can give it voice commands. And so, like, well, I don't, it's like an anecdote, but that's where I got it from. Yeah. So this is an egg. They did that egg one before, where the foot will hit the egg.
I was just going to say, if you could see it right there when he had the hand sideways, that it was still 2 sections in the finger, and you could see the joint in the right there. Yep.
This one. It's enough. It's enough.
It was just before that, but yeah.
This one?
Oh, sure, right there. You could see the inside of the thumb. Oh, there too. Yeah, That's the stuff.
If it can handle this, there's nothing it can't handle at this point. If it can do an egg like this. And it's using its eyes, it's using its sensing in the fingers. And I'm telling you, this was not coded. You could take that egg, put it somewhere else, and it'll be able to just automatically figure out how to do this on its own.
Mm-hmm. Now the neat thing is, and I've been saying this for a while, is if you had a level 5 self-driving delivery van with one of these just tucked into the back with the packages, no need for a cabin even, when it gets to your house, it could pop out and still put your package not in the carport like you keep instructing it, but just like a human would, and put it right in plain sight for everyone to steal. That'd be replacing jobs.
Digit. Right, Digit is being tested in the Amazon warehouses right now, and they're humanoid, but they don't have hands. They have these flippers. They just have these flippers, and that alone is enough to be able to work, because it just grabs the box, moves it, grabs the box, doesn't even have fingers, just grabs and moves.
Yeah.
So this goes way beyond just box moving. This can open doors,
While you're sleeping.
It's like a dance in your room.
This
is the part that blows my mind. It's looking left, looking right, looking down. It's moving those fingers. I love it. This is just brilliant. Guys, who's going to tell me?
It could train your dog. Mm-hmm. Forget walking your dog. It could train your dog. Why
And then
not?
they add this little Easter egg here, which is the dancing part. I mean, look, it's got the fingers. See that? It's got the two fingers. It's doing this. It's doing this. It's got rhythm. So what else is there? Just to take a quick look here. Do you guys notice? Okay, what was that? The lights, just for fun. You see the lights?
Yeah, it's just a
Over the head
neat
there?
design touch.
Yeah.
You think so?
What else could it be?
Well, I mean, like, are you going to be able to read text on the head? Because we just saw another bot figure, and figure has the ability for you to see, it's like a screen, right? So you can show it movements of logo. It can say words on it.
If it's not there already, I assume it would come eventually. That seems like the sort of thing that would be useful, especially when it's maybe not in motion or updating or any of those things.
Do you guys know what's inside the head?
No. Cameras is all I can think of. I would assume
There's
nothing but
nothing in the head.
cameras. Oh,
You know why there's nothing in the head?
no.
Because inside the head is just a metal piece that a cable can grab and hold on to it in the head. And that's why initially they did not have actuators, so the head can stay still. And this part is very strong, so you can just grab it from the head, move it like with cables, like these metal conveyor belts. I wonder now that it's got the actuator, whether or not they remove that part. This is so much more advanced than the last bot, just a million times bot. And I'm sure Scott's going to talk about the hip. This is new. You see that part? That wasn't the case before. And this allows articulation. Mm-hmm.
Isn't it the same general construction? Is it actually different orientation of the actuators than the previous one? Yeah, I would have to look at it.
I got to look again, but that's not what I remember. What did that say, Hans? It said they're actuators, integrated electronics, and harnessing. What do you take from that?
They are doing a lot of the actual sensing inside the actuators, is what I'm reading from that. So, like, basically there's a controller that's integrated into the motor, and a lot of the sensors are integrated there in that actuator motor. They're not having so obviously they're going to have separate sensors in the fingertips, but a lot of their other sensors are basically designed and built right into, whether it's the linear actuators or the rotational actuators.
Yeah. So this is what they do quite a bit of their demos. They love to show off the Tesla bot in front of the Cybertruck. They've done this pretty well the last two demos that we've seen.
So looking at this building from the inside, can anyone figure out where it is? Because it doesn't look like
asking that question.
Any building in Texas that I've seen. No.
Why not? Why can't that be in Texas? Because that's the Cybertrucks. Look at it.
Right? Look at the windows with the overhang there. That's
So I know the last one was built in Palo Alto in the engineering headquarters. I think wasn't it the building that used to be HP's building that they took over? That's where all of the Gen 1 video was taken. I'm assuming this is also there. Could be Hawthorne.
Yeah. Those are facilities that I haven't studied quite as extensively from the air. Or at all. Yeah.
This one here, Tesla bot engineer specifically said this is not CGI.
And there's going to be endless comments about that, just like there was last time and the time before it. The only one that didn't get that claim was the clunky Gen 0.05 that stood on stage and didn't do anything. But this is very smooth. It's also leaner in its overall dimensions than the ones we see in the showrooms. So it's not as deep in the chest, which I think could be some weight reduction as well. I think the most expensive part of this is going to be the chip that runs it. Although those motors, you're going to need to get some scale before those get affordable, but that will happen immediately when they enter production.
Well, yeah, and there's multiple motors for every Tesla bot, so you get larger scale on each motor for every single bot that you make. I think that the chips are probably ultimately going to be the bottleneck that limits the overall ability of this thing to scale.
I'm looking at this view here. So you got your Cybertrucks, you got your different kind of models. Just, what is it doing here? Right?
Right.
Is it an Easter egg? Is it working? This is not a factory. Scott has pointed out when we saw in the previous demo, this is not a factory, but this is a place where maybe for repair.
No, it's an engineering headquarters. I'm almost positive of it. Like, it's either Hawthorne or it's Palo Alto. So these are probably test mule vehicles that the engineering team has done a bunch of validation testing with. And it also just happens to be where they're doing the work. And so it's all kind of happening in the same building. And this is a nice open place to do that. And obviously makes for cool video too.
This is Optimus Gen 1. It looked cool, but for some reason, this one looks cooler.
Well, it definitely does. And the movements are just so, they're getting very fluid. It's got a lot of the right things working.
Did you see that? Okay, wait. Did that right there? Did that look like to you like almost cloth? Like right there?
Yes. Yes,
what
it
is
does.
That?
It's absolutely cloth. But I assume it's just a cover or for aesthetics.
Yeah, because the way that head moves, it gives the cloth is a nice flexible medium to put over that so that it looks good and is protected regardless of what range of motion the head is in.
This bot is gorgeous. Oh my God. This is going to be working. They're not going to sell it to anybody. They're going to use it for just their own factory. But who's going to tell me that this is not able to work today? Okay. Right. And I'm not saying 1,000. I'm still saying maybe a couple hundred, but it can already work now. And my question to folks is, what does the bot need to show you before investors will go, this is inevitable. This company can mass produce this. And they're going to make $1 billion out of this, or $1 trillion. What do you need to know before you make that decision?
I have an answer on that, and I think it is send it to the moon. If it goes to the moon on the first unmanned mission and does a bunch of work, it's going to be
fake.
Well, the people say the moon is fake, but not many. Not many.
Tesla designed actuators and sensors. And remember at the last earnings call, Elon said, oh, we've got maybe 10s, 20s like that of these bots ready, but we're redesigning the actuators. But we think by November, we'll be able to make them in scale. That's what he said. And so at this point, based on the capability, it looks like that they've already settled on this design for these actuators and the sensors, and now they're ready for scale. This looks so sophisticated at this point that wouldn't you agree that they might make 1,000 of them by now? It's not going to be wasted to make 1,000 of these.
Boy. We just don't know. So again, the challenge with bots has always been a lot of companies, Honda included, had really great bots. Their little Asimo was a great little bot, but what it didn't have was the brain. That the compute power wasn't there. It didn't exist. And it's possible also that they didn't have engineers of sufficient capacity to make something like that a reality. But we're at a crossroads. We're at a confluence where all these things are coming together at the same time, and this can finally be a reality. So my only question is Dojo working on this? Is the training cluster working on this? Is that what's holding us back? Because I can think of 100 applications off the top of my head that this appears to be capable of doing today with, I would assume, 50%, efficiency. So what is holding it back? What do you think, Hans?
Yeah, I would agree with that. I think that they're going to continue to iterate on the hardware until the brains are really in a good spot. And while I am very impressed with the physical capabilities of it, yeah, like the fact that it can't walk with a much more natural gait yet tells me that the brains are not all the way there yet. They've got lots of pieces um in place, and they're going to continue to move the ball forward, but I don't think that they are limited on the number of test rigs that they have as far as the data that they're trying to gather to do the training. I think that the core software for both, its movement in the world and doing useful tasks is probably the thing that's holding everything up. And I would expect that to continue to be the case for a while, that um, I just don't see us hitting huge scale. Like they could make this design looks like they could make, yeah, 1,000 of them in the next few months or a year, whatever it ends up being. If they get all that tooling uh, basically ready to go, they could be pumping out thousands of these, in a month easily. But I don't know that they're ready to hit scale on all of that stuff yet. So I think that um, we just have to watch what the software can really do. And they'll be very proud to show us some of the things that that software will be able to do that should kind of give us a warning that, hey, this is really getting where it needs to go.
There are a lot of a demonstration is absolutely what's needed. If at the next AI day it was doing anything mobile in the crowd, even if it's just delivering a package from one side of the room to the other, I think would be huge. If it can do something actually useful, like serve hors d'oeuvres, I don't know, that would be more interesting. But yeah, there are.
And
Boy, go ahead.
What if it can do this? Now turn off the music. Okay, so we know that that was actually CGI. That was fake. That video was fake. But Elon replied to that and he said, "We think the bot can do this by next year. The bot should be able to do this." So, the ability to, if you saw that, he was handing the hat to him, and then one bot hands the hat, the other bot puts it on his head. I mean, this is Gen 1. I mean, obviously, it's a CGI. Sorry, guys. This is CGI. It's fake. I got tricked. Yeah, look at this. This can definitely do this, right? I mean, it can do everything that's in there. Maybe. Do you think it can hold a gun and shoot it? Not, again, the gun part is, we shouldn't be, that's not something we want a bot to do. But
well, I assume the hands are designed to work with any tool that's meant for humans. Can it grip pliers or wire cutters? I assume so. So that would lead me to believe probably yes. I don't know. When Elon said this could be a reality next year, I assumed that was hyperbole, or aspirational. But he's seen all of what we just saw today. He's seen this for weeks or months. So when he said that, I'm starting to think he was being serious.
Yeah. This part just blows my mind, because I think this is one of the biggest upgrades to the bot. Would you guys agree? I mean, the neck actuation, it's not a big deal. It didn't need it really. There's really not that much of a benefit for the head to be able to have 2 degrees of freedom. The walking was improved, certainly with the feet. This is a big deal. The finger sensing. Was there anything else you guys saw that you think that is actually a bigger deal?
In this video, boy, the fluidity of motion is what really struck me. How natural it looks.
Right here, this part here is amazing.
Yeah.
And I would also say the walking with, having that articulated toe section so that it can do toe off, and actually, even though the walking wasn't as fast as we'd like to see today, they have all the pieces in place. You can see the toe is still flat on the ground as the heel is lifted up there. That's going to be really important, not only for walking, but potentially even jogging at some point. And a lot of movement really requires you to actually be able to exert force behind your body, and you can't do that with a flat foot. So that's definitely a big thing.
What do you think about this, the knees?
I don't know. I don't know enough about knees.
I want to compare it to Optimus 1. This is the Optimus 1 right here, right?
Yeah.
That didn't really have much of a knee cover, but Optimus 2 has these knee covers.
Yeah, it would be interesting to know if that's just a cover there, or is there more going on with that?
It looks like just a cover, because if it was to prevent pinch points, it would be ineffective once the knee bends.
Mm-hmm.
So, Hans, you were saying that this version of it is actually very close to the dancing human in the costume, which was so embarrassing when they first showed this. But it is close.
Yeah,
to
the
it
white
now,
color
so.
and the shape, a lot of it looks very similar to that original kind of concept idea.
And if we can do this, this is what that human in the dancing costume did at that very first demo. And here we are, what is it, 2 years later? And we've got it.
Yeah, it was August of 21 was when we saw the first one, right? Yeah. And then I think September of 22, we saw the next up, or of August of 21? I think
here, it's at December 23. That's when.
That's this.
So
that's now.
Gen 2. March 23. So from March to December, that's like.
And then Bumblebee, that's only 9 months.
And then
Bumblebee was September 22.
Oh, was it?
A year.
Yeah, I think you're right. I think August 21 was the first.
Was the AI day?
The first AI day. That's the dancer.
Yes.
If this is the progress from 1 year, a year to 3 months from this, which was, remember, it was tethered. Remember that they had to have 4 people hold it up. People were laughing, saying, "Oh, this thing's going to fall over." It barely did anything. That's the thing I think about Tesla, though, is like they, except for the part where they had that dancing human in them that part was terrible in my mind. But everything else, they show you what they have, and they didn't hide this thing. I mean, this thing was pathetic. It was just there. It was there. And then we were all blown away when we saw the demonstration of the last one. But here we are, a year and a half later. Where is this going to be a year from now, 2 years from now, 3 years from now? So just a matter of time.
One of the comments was, I've got a bunch of comments listing some really great applications like mining. No more risky, dangerous rescues. It's just run by bots that can deal with that. It can do deep sea salvage. It can do space exploration. It can do hazardous waste cleanup. Yeah.
We can have a History Channel show, The Deadliest Optimus Catch.
I love it. I would watch that. I would watch that. Oh my gosh.
Well, I mean, like we were saying, right? There's going to be multiple different bot formats, and for sniffing out bombs, you can still have the dog. You can still have those kind of things. By the way, I should remind everybody who's watching right now that when you read the posts of these Tesla AI, Tesla bot employees, they refer to bot animals. They go bot, Optimus bot, and other bot animals. This is not the only thing that Tesla's working on, a humanoid form. There's going to be R2-D2s. There's going to be various forms, because right now a car is a bot. They refer to the car as a bot, just happens to have 4 wheels on it. It uses the same brain. And now, so Robert Scoble is, well-known tech a celebrity guy. He says that when you turn on the bot, it wakes up and goes, "What form am I in today? Oh, I'm in a car." Then this one is, "Oh, I'm in a humanoid form." Then another one would be, oh, I'm in a bot format, a dog format, and then it figures out its eyes and sensing, and then it goes, and it can do it now. It's the same brain.
Retro Dragon had a great idea. It can run my gas-powered mower.
Because it is pollution, loud. Who wants to do it?
We're halfway there, guys. I feel like the solution is right in front of us.
Well, okay. So let's talk about that, because this is the part that every time I talk to somebody about this and they're going, well, I can't wait till the bot goes in and folds the clothes in my laundry because I hate that job in my home. Why are we waiting for that particular skill? It doesn't need to know how to fold clothes before it's useful. And you can sell billions of these. You can sell 1 billion bots doing package pick and place in factories. You don't need to wait for it to be sold to retail, to a consumer at home, and to be able to, figure out the fingers movement of a folding clothes. Guess what, though? This thing probably could do it already. This fingers here could probably fold clothes. Maybe not yet, but within a year.
And it depends on the clothes. I think it could do jeans for sure, but maybe not silk.
So now I'm the one that's been a little bit too conservative, going, oh, we don't have to wait till it folds clothes. Well, maybe it could do it. This is amazing.
I mean, just like Scott has mentioned, the first place that these will go is factories, and it will replace all kinds of labor long before, because how much are you willing to pay someone to come into your home and fold laundry? Honestly, not very much.
Right.
And so the bots are going to go to those types of jobs that are very simple, very repetitive, very mind-numbing for humans to do, but also that pay well. And so, I don't expect it to be folding too many people's laundry anytime too soon, just because it's going to save the economy a lot more money doing a lot of other things first.
There's a lot of jobs that I wouldn't pay a human to do that I would allow a bot to do. I don't feel comfortable making a stranger clean up my mess. I'm happy to take care of that. But if a bot wanted to do it, I'd be perfectly happy with that.
I don't think so, Brian. You're gonna develop a relationship with this bot. You're gonna be so polite to it.
Oh no, that's what I mean.
You're gonna just treat it like you would.
Oh, yeah, but at the end of the day, it's still a tool. I'm very nice to my smart speakers at home, but
it's gonna be like your pet.
I still let them do work.
No, I don't think so. I think you're gonna fall in love with your bot. You're gonna treat it like your pet, like it's gonna be a part of your family. See, this part right here, I just want people to understand that this was not coded, and it figured out how to put the hands exactly at the bottom of the egg so that the other hand can have a space. And you see how the egg is held by these two fingers, but you know how humans are. We need this space so that I can still hold the egg and have the other hand grab it at the right place, right? They're not going to hit the two fingers at the same place. It figured that out. That's the whole point of nobody coded it. Nobody said you got to position the egg this way and grab. It had to learn how to do that on its own, and that's part of what they're demonstrating here.
Yeah, and I mean, I would say we don't know that 100%, but that is all the demonstrations we've seen in the past, is that it needs to be able to understand how to learn a new task itself. If it can't do that, I mean, we can't code every possible thing into it. It would be prohibitive, but letting it learn on its own would be the only path, I think, to getting it done.
See this demo part? Okay, so it goes Optimus Gen 2. Then it grabs, it looks at his hands, and you see how it did that movement? It looks at this way. It's like have you ever done this test? You ask somebody, and you say, take a look at your nails. And if you are a male, you're more likely to do this.
Oh, really?
But if you're a female, you're more likely to do this.
Oh, uh-oh. I don't know what that means.
Did you not know this?
No, I thought it was the other way around.
Oh, maybe you're right. Maybe I'm wrong. How do I do it?
I don't know.
But I'm just looking at this. This demo obviously is, I don't know, obviously, but it just makes it look so human-like when it did this.
Yeah, just the overall coordination that it has is very impressive. And especially a lot of the upper body movements.
Yeah. I've got a comment here. The 8-hour workday is the key. Every motion is fluid and hyper efficient for battery longevity. Speed isn't the bottleneck. It's the 8-hour workday. And like you were saying earlier, Herbert, if it's going to be working 24 hours instead of 8, instead of taking a couple of 15s and a 30-minute break, yeah.
What do you think about this comment by Johnny? Tesla always engineers the factory at the same time and the product. So I would say the line is close to done. What do you think, Brian?
I have never known that to not be true. That sounds, I hadn't considered that, but that seems like a very good point. At the very least, the thing is, this is so much smaller than any product they've ever built that I don't know how critical it is to design the factory at the same time. But yeah, I don't know. What do you think, Hans?
I just remember that it was only a couple months ago that they were posting positions. I think it was in Nevada for basically the manufacturing manager or the manufacturing lead for the Optimus program. So I would be surprised if, obviously they've got designs and a lot of production processes already in mind, but I would be surprised if they actually have the line close to done. I would think that it's somewhere, still in the phase of planning and design at this point.
So I'm trying to find a clip, but you guys remember that Investor Day, Tom Jew went up to the stage and he was asked the question, tell us about Giga Mexico. And he said that we expect 10,000 employees at Giga Mexico. And he said 5,000 Tesla bots, 5,000 Optimus. Imagine, he said, what our productivity can be with 5,000 Optimus.
I think that's part of what Elon was referring to when
I was going to ask you that.
Yeah. Sandy was talking to him, is it going to be the unboxed process? And Elon was like, he didn't say, but it's like there's more to it than just unboxed process. And I think the Optimus is a very likely candidate for what that extra could be.
Okay, hold on. I just found the clip, and you guys keep talking. I'm going to try to download it.
I'd forgotten about all the job postings for bot manufacturing. What's impressive to me is that they are developing things like the bot, like the FSD, like the Cybertruck, like the Compact we know is underway, and yet the balance sheet doesn't get all blown out of whack like when Meta tried to build the metaverse and you could just watch billions and billions disappearing every quarter into an abyss. This is all being done very affordably, very cheaply, really. And that kind of surprises me.
Okay, I'm going to play this. Hopefully you guys can hear this.
What it takes to ramp a gigafactory? Well, if you have 600 robots, 10,000 trained employees, or 5,000 human and 5,000 Optimus, and hundreds of processes, you can do it. Sounds
okay. So did you hear that?
Yeah. Good catch, Herbert. I had forgotten about that too. Wow.
5,000 humans and 5,000 Optimus robots.
It makes you wonder if the actual production target for Optimus is 5,000 total robots by the time that Mexico was originally slated to be done, which is only about 6 months from now. Not to say that they're on track to produce that many, but that may have been the target.
You're going to get yourself in trouble, Hans. Do you know how many people hit people when you go, I think there's going to be 5,000 robots by next year, and then they're going to get hit with so many people going, you're an idiot.
Hey, I am a certified idiot. No one has to tell me that.
Where'd you get the certification from?
This is my point. My point is this, okay? 8 months ago, if somebody comes to you and says, I think that the Tesla bot is going to be a big business model and it's going to be huge for Tesla stock and company, they go, you're an idiot. You're too optimistic. 8 months later, they see this and they'll go, and you're saying 1,000? No way. You're crazy. 3 months from now, not going to go. You know what I mean? Like they just continue to change it in a matter of a year or two.
Well, and there were so many people when the first and second demos happened saying, look, all these silly things, they're not going to happen. They're not real. Other companies have gotten to this level so much more quickly than Tesla has. And I'm saying, right, but are you looking at the pace of innovation? Because it is moving real quick. And we haven't seen a company go from 0 to 60 in this kind of speed. And I don't know if 60 is fast enough for this metaphor.
I did want to touch on the, there's a lot of comments that talk about, a Tesla bot could build more Tesla bots. And anyone who has built 3D printers knows that the problem with a 3D printer printing more 3D printers doesn't have anything to do with any of the physical parts. It has everything to do with actuators and chips, and Optimus bots are not going to be manufacturing chips, and they're not going to be manufacturing actuators either. So unfortunately, just because you have a giant fleet of bots doesn't mean that you can suddenly double the number of Optimus that you can put out. You actually have to set up new chip fabs, and that's a whole different thing.
Well, I've never heard anything about the chip fabs running behind, and we do know that Taiwan Semiconductor is building a factory in Arizona to manage the to build out hardware 4 if they're not already doing it. So it could be that entire second factory or the entire original factory could be dedicated to making chips just for Optimus.
Yeah, I think we're going to have plenty of room to ramp up to very high levels. If they're planning to have 20 million vehicles that they deliver in 2030, then obviously they've got capacity lined up for a lot of FSD chips, and Optimus should be a fraction of that in the near term. But it's when people start talking about going from millions of vehicles to billions of bots, potentially 10 billion bots is what Elon said, that once you cross over the threshold where you're producing way more bots than you are automobiles, that's where you've got to really start looking at your chip supply.
But we're already at millions on cars, so getting above millions of bots, I think they've got a few years to get to that level for sure.
Yes, definitely.
It's a good question here, guys. Can you answer this?
I can't, but
I think it's coordination.
For a second.
No, I think this is definitely coordination, that it trying to do all of its balancing in motion is something that it just doesn't have high enough coordination to do yet.
Because I would say the actuators have the fidelity to do faster movements, but it sounds like you're saying maybe compute is the limitation. And if that's the case,
it's the control algorithm. Yeah, we just don't have yet a high enough quality control algorithm for that. And so that's where those are the types of things that I'm looking at when I'm saying I don't think the brains are ready yet for them to start scaling up things. Like this thing needs to be able to move like the Boston Dynamics robot without having all the mistakes and stuff that does dynamically, obviously without being hard coded. When it gets to be able to do those types of things, that's when it's really ready to have tons and tons and tons of bots being manufactured.
One of the comments I just got was that Elon wants to keep the speed slower than a human for, peace of mind, safety. But I don't think what we're answering is the walking speed so much as the speed of doing any given task, because it can do any dexterous task at different speeds, and ideally we want to get them up fast. Yeah.
So, this improvement, right? So we just look at Optimus Gen 1 to Optimus Gen 2. I think you guys calculated 9 months, right? 9 months? Yeah. But look at the improvement. The improvement was everything. It wasn't just, the hands. It's the hardware changed almost everywhere too. It's just a totally different look almost. The only thing that didn't change was the head, it appears to me. But now you got the neck movement, you got the finger movement, you've got the foot being able to make changes. They changed. I honestly got to ask Scott, but I believe this part right here in the center was completely different than it used to be.
And where's the belt buckle?
See, that's my point. Remember, there
Yeah.
used to be a solid piece. If you look at the, I wish I had a photo of this one, but it wasn't that one single spine.
Yeah.
I
Yeah,
think
the
that's a different
actuator at the
actuator.
base of the
Yeah,
hip.
that's a totally different actuator, Hans. That's not what they had before. Look at the hip. You
Same.
know, see this hip, by the way, guys? Scott, Walter, and I do many different videos, and we dive deep into lots of the other competitors. The hip, normally for other bots, is massive. They're huge. And they're not the same actuators that you would use for the shoulders or the elbows. And I tell you, one of the things that Tesla's doing is they're making all their actuators used like it looks like here that the hip could actually be the same ones being used for the shoulders. We'll find out. Maybe even the same one for the maybe no, it looks like that the elbow's a little smaller than these ones, but these are tiny compared to the other bots that I've ever seen. But and the reason why that matters is scalability of manufacturing. Tesla is focused on scalability. If you look at Boston Dynamics, the CEO of Boston Dynamics was on a podcast. I think it was Lex Friedman, and he told Lex, "We did not build the Boston Dynamics bot for manufacturing. This was a demo. This was for demonstration purposes. We spent 20 years making sure that it can move like a this ballet kind of movement just to show it, but we did not. That's why it's so big. That's why it's so massive." And then their the board of directors, which I believe is Sergey Brin, from Google, they said we need you to make a bot that is manufacturable, scalable, and he said we can't do it. And so today they're not selling their Boston Dynamics bot; they're selling the dog. That's what they're focused on right now.
Well, and the ostrich, and I think there was another one they might actually be selling. The ones
the ostrich
for
is the
packaging.
thing in the factory.
Right.
For packaging, the factory one, but not the Boston Dynamic one that everybody knows.
Right. And I think that was a perpetual fundraiser machine that they were building. Is that is what gets the next investment and the next one. And here we are 25 years later, and they're barely producing a product. What's it going to take? A good question came up. What's it going to take for Wall Street to get on board?
That's what.
Yeah, I know, but I want to go back to it because it is the question. Herbert, what's your answer?
My answer is this. I mean, we've been saying this for a while, and I said that when you see a demo like this, it doesn't change the investors, but more and more investors realize that it's inevitable. And once they realize it's inevitable, they will start investing. And that's what happened. I think they need to do more demos like this. And then once they show this in an actual factory and say we're actually using it now, that's the stage where more and more people will dive in.
And as a recruiting tool, if you work in robotics or you've just graduated and want to work in robotics, there is no second place behind this. Where else are you going to go to get your design
show you guys,
into a product? Go ahead.
Something I noticed. Okay, so watch this bot, look at his arms, but as soon as it finishes doing that, it makes this kind of movement where it shifts its weight. Right there.
Mm-hmm.
This is the thing that Scott Walter will tell you. That movement right there,
Yep.
that was not coded. This is the bot understanding its body and the different weights, and it learning on its own through just like you and I. Like a kid wakes up and moves, and it figures it on its own. That little movement like that, that's beautiful, because that's when you know that the bot knows. It learned it on its own. It coded it on its own. It's not like it's acting in real time. That's gorgeous. You see that?
Yeah, and that speaks to the fact that the coordination is getting there. So those types of things where you're going to reach over and you've got to move multiple different joints in your body to make a movement, that's much more difficult to do if you've got all this hard-coded stuff. But when you have this organic learning that's going on and its ability to do that, it will move if you give it the freedom in a way that helps it to stay balanced, for it to feel natural, for it to look natural. And so while the coordination is not as good yet as human, it's getting much, much better. And especially it's better than most bots that we've seen.
A comment that just came in said, when the bot picks something up that only needs 3 fingers, it partially closes the others, probably because it was trained by watching humans. What do you think of that?
Yeah, I think that that's likely, especially in the video that we saw where the person was wearing the whole outfit and that had the sensors on the head and everything, and it was doing movements. So I think that that's highly likely.
Yeah.
Somebody here, right here, said this. I think the bot is being remote controlled by a human. So
No.
just to be clear, it is not. Many bots are trained remote controlled by humans. Many bots, we've seen them. A human puts on the headset, puts on the gloves, and as the human moves it, there's a, like I'll put it on right now. The bot beside me will do exactly what I'm doing. And then that's how they train it. This is not. It can be done this way. They can do that. It's remote control. That's part of the training. This was not being done this way.
If you look at any advanced puppetry, and I'm not joking, actual advanced puppetry, something like Yoda will have sometimes 5 different puppeteers running it. If you look at something like BattleBots, where you've got just one little robot with some weapons on it, it can take 3 different operators running it. This is too much. This you would have more failures trying to control it remotely than you would letting it learn to do it itself.
Okay. So Hans, you sent me this photo. This is the Optimus Gen 1, and you're telling me that you believe that this hip and this spine is the same.
I do. I think so. The front of it does have that extra little cover over those 3 actuators, but I think the actual actuator configuration is the same. They just removed that little dog bone kind of looking piece there in the front, or boomerang almost. So it's still one motor that goes up and supports the back. That's in between those. There's actually 6 motors there. Each hip is 2 motors that are the same motor, but they're attached so that it can, the leg can rotate this way and this way. So there's one motor for each of those axes, and that's what you see at the.
Okay. It's just
There's
it's been refined.
Configuration for the upper body so that it can twist this way and so that it can lean back and forward.
And looking at the simplification in there, these bones are very rugged compared to what we've got now. All of these electronics, it's beautiful to see the simplification in action.
Yeah, let's take a look at all the differences. So first of all, this is what I was showing you. This was the foot for many versions of the Optimus. It's just a flat piece of metal. That's all it is. And it barely has an ankle. So it plods, and that's why it has to stoop when it's walking. Look at the fingers. Fingers are beautiful, but they're not articulated. I don't know what the right word is.
They don't bend.
Yeah,
they don't have multiple joints.
Look at the shoulders. Now they could be covered because it is now covered with that thing. But look, these looks much bigger.
Those do look like the hips.
Yeah, that's what I'm saying. See, that's the thing about Tesla. They will take that same actuator that's using for shoulder and they'll reuse it for other parts. Yep. So it's actually one line item, one SKU. And then that's the neck and head. And look at the chest. It looks just so strong here. So this is what it looks like. And let's compare it to what this looks like. What do you think? That? To that.
I just can't, the amount of change from one to the other. I think, a lot of the core components are the same. I do think that those actuators in the shoulders are going to be the same, that all the actuators are the same from one to the other, but everything around it has changed so dramatically. And for them to be able to make that much of a design update in 9 months is mind-blowing. But then, because they did add, so they made actuator changes in the neck, and so there are some actuator changes that have been made as well on top of all that.
We're just watching history unfold in front of us, and this is a very exciting time.
Yeah.
Okay, I'm just going to show one more thing.
One of the things that I really enjoyed from Walter Isaacson's biography was the little snippet about the origin of the Optimus bot program. That basically they put out the first AI day when they had the dancer and they did the one more thing, and that basically the next day all these people just started showing up to work on the Optimus bot, and that was, they were just taking these off the shelf parts to put something together as the first prototype, and that's what ended up being that Bumblebee version. And so then this just ad hoc team of people who, the reason they're showing up to work on this is because this is a passion for them. So it doesn't surprise me, like the results that we're seeing is a team of highly motivated, highly skilled, and highly passionate people that are really working on the edge of the field of robotics, who don't come with a whole lot of prior assumptions about how everything can and cannot be done. And they have the resources of Tesla, not only in their ability to manufacture things, but then the electronics that they have to work with, the actuators that they know that they can design in-house. And so it's just a masterful combination of things that makes this possible.
Trying to show it side by side so we can compare it much more closely, but I can't do it. Sorry, guys. Don't know how to do this. But does the head look smaller? This is the original version. This is the new version.
I think the shoulders are narrower. I don't know. It could just be an optical illusion with the way the shoulder cloth is draped further on the new one. Oh, I see. The whole line is different.
The lights are awesome. I like it.
Yeah.
That's new. This is gorgeous. Okay, well, thank you so much, guys. I hope you guys enjoyed that. I'm blown away. Like you said, this is a history in the making. We are capturing that. We're watching the development, and I'm telling you, Tesla, the bot is going to just make this company just crazy successful. Even if it can just help with the car manufacturing, the cost for the automotive gross margins will plummet significantly. So this is a big deal. Thank you for joining, guys.
Thanks, Herbert.